Well, hey y'all. Yeah, so guess who left with COVID? Yeah. So, yeah. So I know my nose sounds funny and I know I sound funny, so shut up. Um, Now, I hope you guys are doing good and you had a good uh, Labor Day break. I'm going to try this and we'll see how it goes. And I'm going to be drinking lots of water, probably. Might even run off and get a cough drop. I don't know. We'll just see. We'll just see how this goes. But I wanted to at least try and move us along a little bit. And I mean, who knows? I mean, tomorrow I may not be able to. Who knows? But we'll see. Anyway, to move us along and um, yeah, we'll just make it work. So I know we were kind of in the middle of something. Okay, you guys were doing. We had done the review sheet, right? And we couldn't do up to a certain point. And then afternoon classes, physical science, that is. You guys worked on those review packets too. Mr. Davis had you work on those. So, um, hang on just a minute. Someone from down south has texted me. Hang on just a minute. Just bear with me. Yes. Okay. So yeah, that's going to start a whole another thing. All right. So what page do we be on? Well, I'm thinking. I think we put stuff on page 6. Did we put stuff on page 6? Some classes did, some classes didn't. So I'm thinking that what we do, gang, is we put this on page 7. And this is stuff you just need to write down. There's a little bit, like 3 lines we're going to write down. We're going to write down some math formulas, and then we're going to go through some examples of how to implement them. And I'm going to talk you through, but you guys got to think along with me. You can't be playing. Robert, stop playing. Um, and Gotcha. Um, so page 7, everybody needs to go to what the equivalent of page 7 and number that. And then at the top, we want to write this. We want to write gas laws. And this is not real exhaustive, and it's really not that hard, but it is a little piece of something because it relates to what the particles are doing, right, in gases. Um, and so we want to tackle that. Now, we're going to do this, and then we're going to do the assumptions of the kinetic molecular theory, but that'll be a little bit. So page 7 is this, and then probably page 8 would be the other one, and then you should be able to wrap up everything in the packet, and then we'll do um, try to work with this a little bit more. I feel like we need to work with things a little bit more. But this is, again, everything we've been doing in this unit 1, so to speak, has been just like little appetizers of some concepts, but they totally relate to everything we're doing the rest of the year. Because everything in that we're doing the first semester is about particles, right? And things on the periodic table, right? So those little doodads in the boxes, the atoms, whether it's molecules, which we've talked about, or atoms, they're particles. So gases, we know that phase of matter, right? We've got things, enough energy is in things that they're moving around and they're bouncing around. And we could probably come up with some easy examples of things that at room temperature, at temperatures that we can stand, that exist as gases. Helium does, oxygen can, right? And then CO2 does, right? So there's certain elements up on the periodic table that are gases at what we think of as room temperature. So based on some things that science has seen over time and some theories that came about, these actually came about more like in the 1800s. It really did. Some of these laws and people, messing around with gases and seeing how they behaved. Ryan, you with me? Okay, good. Hi, Ryan. Stay with me. Stay with me. All right. Oh, let's see. Well, here's the first law to write down, and I'm gonna give you a hint as to how to remember it. I just realized that this is gonna get really. If I was in, okay, let's just move forward. Okay, yeah, because there's some interesting gas laws coming up here. So, all right, well, the first one is very simple, and to remember his, all you got to do is just think of like a straight line as something boils, right? It goes from cool to hot, right? Straight across before it boils. That's the name of the law. It's Boyle's law. And that's the way it's written. So we've got volume 1 times pressure 1 at the beginning. So V1 and P1 are at the beginning of the story. Okay? And then yeah. And then V2 and P2 is at the end of the story. Well, now, as any good math problem will go, you have to know 3 of these variables in order to solve for the 4th one. And most of the time, you're going to be doing that through division. Right? So, okay, time out. Let's just think about this as an algebra problem. Algebra that you guys have been dealing with and are dealing with and have dealt with, I'm sure. If you didn't know V2, if the question said, what is the final volume of the gas? Well, wouldn't you divide both sides by something that you knew, like P2, pressure 2? They would have to tell you the pressure, right? You divide both sides by P2, and then it starts to become easy, right? Because if you put under each thing here on either side of the equal sign, right, you just draw a line, and then you put the P2 underneath of it. Over on the right, they cancel each other out, and you're left with V2 on that side. And so V2 equals volume 1 times pressure 1 divided by P2, and you have to have been told those 3. Sure. And that's how you solve it. You just got to pay attention in every one of these. What are you given in the problem? That's it. So here's the second one. There's only 3. Okay, here's the second one. And as long as that makes sense. And feel free off to the side if you need to write volume and pressure, around those. Absolutely, by all means, do that. All right, let me check my time here. Doing good, doing good. All right, next is Charles's law. And see how I have the forward slash? Well, that's the way the computer liked it. But I would, when you're writing it down, I would write V1. Do it on a sheet of paper. Right here. And let me find something big, fat to write on. V1, and then put it over T1 like this. Hold on. Let me show you. Like that. Can you see it? I would do it like that. Because V1 over T1 equals V2 over T2. V being what? Volume. And T being temperature. T being temperature. Yep. And so when you're working with Charles's law, think of it this way. Think of it this way. Things are given in division, right? Division is dividing, right? Splitting it into smaller parts. Well, how do you undo division? You multiply. Mm-hmm. Yeah. So if you were if you were given, took drugs for my nose and now my mouth won't work. If you were given, I don't know what, volume 1 and V2 and T2, you're trying to solve for something on the bottom, T1. Maybe, just for example, write that out, right? Numbers, well, we're going to do examples, but so you would multiply, wouldn't you? You would multiply. And in that case, probably, as I'm recalling, I think you're going to multiply. Yeah, you're going to multiply, and then you're going to divide. Right? Sounds good? All right, so there's the last one. Oh, and if you wrote it like this, here's how you can remember his law. if you ever had to identify it, let me turn it to where you guys can see it again. See how V is on the top? Well, V is the Roman numeral for 5. So, no, wait a minute. No, don't get confused now. Volume means, V means volume. Daggone it. There we go. V means volume in this case. But it also looks like a 5, doesn't it? So when you're trying to remember, how does Charles's law go? Or what's the law that has the V on top? The way I told it last year was Charles V sat on the T, the throne. Charles V, V, sat on the T, throne. That's how you remember Charles's law. Charles being King of England some time ago. Alrighty, well here's the almost hesitate to do this with you guys, but this is the last law. Okay. Shh. Okay. All right, Gay-Lussac. If I was in class, I would give you an easy way to remember this. No, I am not doing it on video because, anyway. That one is P over T, pressure over temperature. Now, yes, there was actually a scientist, Gay-Lussac, right? It's hyphenated, Gay-Lussac, and it was somebody's last name some time ago. But each one of these scientists found that there is, the big takeaway here, guys, is there's a relationship between volume, pressure, and temperature of gases. Hold up. Of course there is. Remember what I told you about the air in the tires? You put air in the tires. I told you that on purpose because I'm sneaky. Like if we fill up our tires. Fill up our tires with air. Be quiet. I'm taking NyQuil. If we filled up our tires with air in a warm climate, didn't I just mention to you volume of the tire? Fill up, pressure in a warm climate, temperature? I did. Now, I didn't give you any numbers because you can wrap your brain around that concept. Well, when you're trying to work with these, it's the same thing, y'all. It's the same thing. All you got to know is what units to throw next to the numbers. And as I taught chemistry, I learned that to really do these problems correctly, like the way they're supposed to be doing it, we have to use very specific numbers. Units. We have to use very specific units if we're going to do them correctly. But I made this PowerPoint at a time when I didn't quite know that. So we can come close. And if you can calculate things, since you guys ideally don't have your phones on you, and to actually run the numbers, we'd have to calculate them. Here's what I'm going to suggest. As we go through these, just set the problem up so that if you got your hands on a calculator, you could solve it. All right, so I'm going to walk you through how to solve a few of these, but we're just going to take real scenarios, and I'm going to give you all these formulas, excuse me, at the top, and they're going to be listed on the top. And the big trick here is when we read the story, trying to figure out, one, which formula do we use, and then it's going to be really hard over video because I can't hear you. If you shout loud enough, maybe I could hear you in Maysville. I don't think so. I don't think so either. But is setting up the problem. And by that I mean set it up just like you would next door, right? With Mr. Applegate. And you guys in sixth period, if you get confused, yeah, you can just ask Mr. Applegate because he's sitting in class in the back. Because I'm sure he can do math really good because his daddy's a math teacher. All right, here we go. Yeah, no pressure, bud. No pressure. No pressure. No pressure at all. Okay, so here we go. I think this is going to work. Well, maybe not. I thought it was going to work. All right, let's see if I can make it work this way. Well, I'll be daggone. No, wait. I got to make it click somehow. Yes, I'm pushing the button, and it's not doing what it's supposed to do. Well, if I did enter. Nope. What? just does not like what I'm doing to go to the next slide. What if I did that? All right, what if I did this? You know what? I can't go to the next slide. Well, I guess we'll make them up because I don't want to stop this. I do not see any options on this here screen to make the slide go forward any. And I'm hitting the space bar and it not doing what I want it to do. You guys can probably hear music too. I'm doing that. Oh, this is really irritating. Forward, advance, up, down. No, no, no. Not there. Oh, that's just nice. I don't want to do that. That's just amazing. All right. I'm going to make up some problems as we go because I'm not stopping the train. It's a moving. All right. Well, you guys have all three of those problems there, right? All the formulas there. So let's walk through an imaginary situation. Okay, here's fake story. Fake story number one, and you tell me which it is. I'm going to tell you the units that we're going to stick with. For volume, okay, here's the units. I would write this off to the side just so you don't get lost. For volume, it's typically going to be in liters or milliliters, which is a little m with a capital L. Volume is going to be liters, which is a capital L, or little m, capital L, milliliters. Okay, liters. You know a liter, right? You guys buy a 2 liter of soda, half of that. Okay. To do this in pressure, we're going to use this thing, and this is the right unit to use more often than not. It's atmospheres, and the way we write that is ATM. ATM with a period. So pressure, our unit for pressure is going to be little a, little t, little m, atmospheres. Okay, and then the other unit, temperature, this is where it gets flaky. We're supposed to use this thing called Kelvin, but we're not going to do that. That's getting a little bit, I don't want to put too, much on you. Can you convert from Celsius to Kelvin? Yeah, easily. But I don't want to throw that step in there right now. I just want to get used to hearing information and figuring out which law we have to use. Just a little bit of practice. Okay, and this is probably not going to go very long. Okay, but at least you had something today. All right, and that unit for temperature. So what we're going to use for temperature, let's just use degrees Celsius, which is the little degree symbol and then a C. So for temperature, we're going to use degrees Celsius. We're supposed to use Kelvin. We're not going to use Kelvin. But in chemistry, when y'all take chemistry and you're dealing with these, you absolutely, to do it right, you got to change it to Kelvin, which is not hard. And we'll deal with it when I get back. But we're going to use degrees Celsius. All right, so one more time. Volume, we're going to use liters or milliliters. Pressure, we're using atmospheres, ATM. And temperature, we're going to use degrees Celsius. Okay? Those are the units that we're going to roll with because that works. Okay, so here's scenario number one. So come down from what you wrote in there, since I can't get this to work. Come down from where that is on the sheet, and let's write this down. Okay? And I'm kind of making this up on the fly, so bear with me. All right, I might want to write this down before I say it. I'm trying to remember the scenarios. Oh, okay, I got it. Okay, hang on. Hang on. Here's at. Hold on. Hang on. Ooh, that's a good one. Okay, I got it. All right, here's the story. All right, we got a propane gas tank sitting on a grill outside. Very, very common. No, you can't blow it up. Okay, geez. Jordan, You can't. No, that's not what we're here for. No. All right. There's 2.5 liters of gas in a propane tank. I'll give you time to write that down. At 78 degrees, Celsius, the pressure is 2 atmospheres. Oh, this is good. What will the pressure inside the tank be at 55 degrees Celsius when the sun goes down? Question mark. Now, okay, so one more time. We got 2.5 liters of gas in a propane tank. The pressure is 2 atmospheres. Well, you know what 1 atmosphere feels like. It's pushing on you right now. It's 2 atmospheres at 78 degrees Celsius. That's a hot day, because I didn't say Fahrenheit. I said 78 degrees Celsius. That's a pretty hot day. Yeah, it is. That's like almost, yeah, that's pretty hot. All right. If you convert it to Fahrenheit. All right. Then the question is, what will the pressure inside the tank be at 55 degrees Celsius? All right, so what have we been given? Now think about it. Stop and think about it. Read everything that you've got at the top of your page and think about it. I'd say I wish I could hear you, but what have we been given? Have we been given volume? Do we know V1? Do we know the volume at the beginning of the story? Yeah, tell somebody. Tell somebody what it is. Good. Yep, it's 2.5 liters. Now here's my question. Is there anything in the story that I just told you to imply that we have lost any gas? No. So do we actually know V2? We do know V2. It's the same. It's the same number, right? Okay. Do we know beginning pressure? What was the pressure? Turn and tell somebody what the pressure was at the beginning of the story. Everybody should be holding up 2 fingers right now, because that pressure is 2 atmospheres. Glory. All right. Yeah, 2 atmospheres. At what temperature? Oh, we just brought this in here. Now, okay, at beginning temperature, well, we know T1, don't we? We know temperature 1. What is that? Somebody shout it out for me. Wave that hanky. 78 degrees. That's right, 78 degrees. So I gave you 3 pieces of information, didn't I? But we actually only need to use 2, meaning at the beginning. They want to know P2. See? They want to know P2. What's the final pressure at a temperature? Well, is there anything, which law up here deals with temperature and it deals with pressure? Gay-Lussac, that's right. Gay-Lussac. So the volume is kind of inconsequential because it didn't change, did it? Right. So that's kind of like useless information. I just wrote it down because I wanted to keep track of it. But so we don't need to worry about the volume because the volume didn't change. All right. What we really got to deal with here is what the P2 is, and we know T1 and T2. So how do you set it up? I wish I had my little dry erase board. I mean, my itty bitty one. We would have to put P1, which is what? What number? 2. 2 atmospheres. We put 2 atmospheres down, and then we draw a line. What is our T1? Beginning temperature, 78, isn't it? So that goes under P1. So we got 2 over 78. Well, what symbol goes in after that? Equal sign. All right. Do we know P2? Do we know the final pressure? No, that's what I asked you for, didn't it? Right? So P2 goes on top. And then our final temperature was what? Somebody shout it out. Oh, I heard that. Somebody said 55. Dry 55. Not in the middle of town, though. You'll hit deer. Yeah. So what we got? Here's the way you set this up, y'all. We got 2 over 78 equals P2, right? Because I don't know what that is, divided by T2, which is 55. Right? All right. So now here's the question. How do we solve it? Right now it's in division. And let me ask you again, how do you undo division? You multiply. Can you multiply by some number here? What number do you want to pull, let me just put it this way, out of the basement? You want to pull T2 out of the basement, don't you? You're going to multiply both sides by T2. Right? Because he's bothering us down in the basement, right? We don't want anything in our basement, right? Multiply both sides by T2 to get rid of him. And when we do that, when we pull them up on the line, don't they cancel each other out? On as you wrote it over on the right? Because now, let me just pause there. If you wrote P2 and then you wrote T2, which is 55, next to it, didn't you? You just wrote 55 next to it. Well, now you got 55 on the bottom, don't you? Don't they cancel each other out? Sure enough, do. So now what you've got over on the left, you should have 55 that you just wrote times P1, which was 2, divided by your beginning temperature, which is 78. And that was good. I didn't intend for it to be necessarily Gay-Lussac. I just ended up with too much information. But that's how you go about setting up one for Charles's law, and the same way with Gay-Lussac, you multiply. But we should probably do one for Boyle's law. So this is going to be example number 2, and then I'll walk you through that one, and then we'll just kind of stop. And let me make sure I don't give you too much information this time. Blah, blah, blah. Oh, good one. Okay. Let's see. Hang on. I'm going to stick with low numbers at ooh, that's good. Okay. All right, here we go. All right. Imagine a balloon you can blow up to about this big, right? Yeah, I know. If Ryan lets it go, it's going to go all over the place, right? Yeah, because that's what Ryan likes to do. I know that. Okay, so pay attention, Ryan. Okay. All right, so here's the idea. The balloon's full. It has 2 liters. Do you know of anything that is 2 liters when it's full? Exactly. All right, so basically it's the size of a soda can, or soda bottle, right? 2 liters. It's 2 liters when it has 1.5 atmospheres in it, because you blew air in it, right? Okay, 1.5 atmospheres. So what volume would it take up after you let some air out if you only had 1/2? Stop. How do you write 1/2 in decimal? 0.5. If you let a bunch of air out and it only had 0.5 atmospheres in it, what would be the volume? Can you calculate that? So I gave you volume 1 and I gave you pressure 1. I gave you pressure 2, but we don't know volume 2. Whose law is that? got it. Boyle's law. That's right. See, this is not bad. I told you it's not bad. All right. So let's set it up. Let's set it up. What I would do for number 2, I would write down Boyle's law, because we know what that is. V1 times P1 equals V2 times P2. Yeah, write the formula down and then plug in what we know. All right. So let's see. What is P1? Pressure 1 was 1.5 ATM. 1.5 atmospheres. Okay, but that gets multiplied by 2 liters, right? I kind of did them backwards, right? Or did I? Well, yeah, I did. Yeah, P1 is 1.5 ATM, atmospheres, in parentheses, and you're going to multiply it by 2 capital L, 2 liters. So that's V. I gave you P1 times V1, but it's the same thing as V1 times P1. Stop. Yeah. All right. So what symbol goes after that? Equal sign, right? Cool. All right. And do we know V2? Do we know the new volume of the balloon? No, we don't. We don't know that. But we do know the final pressure, don't we? We do know P2, which was what? 0.5. Right. So after the equal sign, we're going to write V2 times, or just in parentheses, 0.5. Let's see, 0.5 liters, L. And then close the parentheses. Don't forget to close the parentheses. They feel naked if you don't do that. All right. They get all embarrassed. Well, you got to do the math right. Okay. So now this is all set up as a multiplication problem, right? Because we've got 2 times 1.5, but then it equals P2 times 0.5. So it's all tied together by multiplication, so now we got to undo that. How do you undo multiplication? Do it by dividing, right? So what could we possibly divide by to get P2 by itself? Excuse me, I said it wrong. To get V2 by itself, just the V2, which we don't know. How do we get rid of it? We divide by both sides. We divide both sides by P2, right? So under each side, right, we've got the V1 times P1, right? Draw a line, like a dividing line. And then you're going to put the numeric value of P2, right, 0.5, under both those lines. And if somebody gets confused, you got to holler out and help each other. Or somebody go up to the board. You stop the video if you need to. Somebody go up to the board and draw it out. That's a good idea. You can pause the video if you need to do that, just so that everybody has it right. That's a great thing if somebody would do that. Okay. So now that we've got it set up, what we have to do is your final math problem is going to be multiplying V1, which is 2, times 1.5, right? And then dividing it by, once you do that math, you divide it by 0.5, right? And now we've got V2 all by himself, and once we do the multiplication and then the division, we should know what V2 is. And then volume is going to be reported in liters. And if you're really, really nitpicky about the canceling out the units that you wrote down, you would find that liters is the only thing that remains. So anyway, there's another example, but it's later in the PowerPoint. I have to figure out what's going on with this because we got to be able to move through other PowerPoints. That's probably good for now. But I'm gonna quit, and that way, if you need either one of those problems written on the board, somebody can write those. That would be a big help if somebody would do that. So that's all I got, and so far so good. I just got a stuffy nose, feel a little bit weak, and it started really hitting me Friday after lunch. Something just was not right, and I knew it. So I did a COVID test Saturday, and you guys probably seen the home tests, and you get the one line on top, but then the other one was kind of faint and faded, but it was there. But then I did one today, and boy, let me tell you, I had me some 2 red lines. They were like that. So I was like, well, yeah, I got it. So anyway, hopefully I can do another one of these for you guys, and we'll see how far we can get, because I don't want you guys to fall behind just because of this. So hopefully it works. So y'all have a good day, and I will see you soon, I hope. Bye.